Hello everybody, welcome to Machine Learning Algorithms. I'm Adarsh Datta, the startup evangelist from Microsoft Canada. In my conversation with quite a few startups in the last couple of months, one of the most interesting discussions come across is as to how they can use machine learning in their products in order to improve the product. And the biggest question that they have is where do they start and how do they start? So me and my colleagues have been working on this series of tutorials, which is educating a lot of startups, students, machine learning enthusiasts, data scientist enthusiasts, and anyone who's interested in anything to do with data and educate them about machine learning. So what is machine learning? So machine learning is essentially using historical data to make predictions. It's not only about predictions, it's also about finding out whether there's some kind of an anomaly happening in a particular set, in a particular setting, in a particular experiment. And it's all based on relationships and pattern finding within the data. In general, the machine learning process can be broken down into 5 basic steps. This has been covered in other tutorials, but that's the reason why I've just schematically represented it. Step 1 and step 2 is about collecting and making sure that you have the right data set. So you essentially have data, and then you massage the data, you clean the data in order to make sure that you are using the right optimized data set to have an optimized machine learning trained algorithm. Once you have your structured data set, you basically split it into 2 parts. One is called the training set, on which you will be applying your algorithm, and the other part is called the test set, against which you will be testing the trained model, Step 4 is about applying the algorithm on to the trained set that you have extracted in step 3. Now, this is the most interesting and probably also the most important part, because you really need to understand what kind of algorithm you want to apply to your data set in order to get the right results that you want to achieve. And this is why I'm going to focus on what kind of algorithm you want to use in what kind of scenario. So once you have your trained model, all you need to find out is whether that trained model is good enough or not. That's when we come to step 5, where we score the trained model and we try and evaluate the performance of it. So overall, these are the 5 steps which comprises of the machine learning process, and we're going to focus on step 4 and step 5. So the first thing we want to determine is what do we really want to do? Based on that, you collect the exact data set which is going to give you the answers. Once you have the data set, then we can actually look into this 4 different kind of scenarios which exist, which are classic scenarios for machine learning. The first one is if you just want to predict values, and I'm talking about a continuous set of values. So for example, if you want to predict the product demand, you want to predict sales figures, you want to analyze marketing returns, you want to even predict the price of the next car you want to buy. It means is that what you're trying to do is predict a continuous set of variables. This is when we use regression algorithms. The next class of algorithms is whenever you want to find unusual occurrences, and this is what we call as anomaly detection. So for example, you want to predict credit risk, you want to figure out if there's some kind of a fraud happening, or you want to catch some kind of an abnormal equipment reading. So all of this comes under anomaly detection, and there are certain algorithms which you want to use which are specifically focused on anomaly detection scenarios. The third kind of algorithms which exist is whenever you want to discover some kind of a structure and you want to use clustering algorithms. You want to use k-means, you want to use Bayesian, and all those different kind of algorithms whenever you want to probably perform customer segmentation, predict customer tastes, determine the market prices. And finally, and probably the most common one, is whenever you want to predict categories. Now, the difference between predicting categories and predicting values is that predicting categories has a finite set of classes that you can predict, okay, based on as opposed to predicting a continuous variable which can have infinite values. In predicting categories, there essentially can be two different kind of algorithms. Either it's a two-class or it's a multi-class, which really means that whenever you want to predict a binary set of results, which means a 0 or a 1, whether a plane is on time or not, whether the tweet sentiment is positive or not, whether the customer will renew the subscription or not. So that's a binary set of decisions that you want to predict. That will fall under the two-class categories, and you would want to use two-class classification algorithms in order to predict that, as opposed to a multiple set. For example, what is the mood of this particular tweet? So you can have 4 or 5 different kind of moods. You can be happy, you can be sad, you can be neutral, you can be elated, or you can be disgusted. So there are 5 different classes you want to predict. That's when you want to use a multi-class algorithm. You might want to figure out if at all an image resembling a letter is either A, B, or C. In that case, you can have 26 different kind of predictions. Therefore, that particular kind of an algorithm will have 26 individual classes, and that's called as a multi-class algorithm. So just to reiterate, the 4 main categories of algorithms that you want to use is either a regression algorithm. You'll be using a regression algorithm when you want to predict a continuous set of data. You want to use an anomaly detection algorithm whenever you want to find some kind of an unusual occurrence. You want to use clustering algorithms whenever you want to discover structure, and you want to use classification algorithms whenever you want to predict categories. Under classification, it can be either a binary class, which is basically a 2-class algorithm, or it can be a multiple class algorithm, depending upon the way you want to use it. Now that we've covered the 4 different categories, there is a beautiful cheat sheet which has been created, which essentially talks about what are the different algorithms which exist and which one you should use. So as you can see, the different kind of algorithms are categorized under the colorful boxes. So the first one you can see is anomaly detection on the top left. That's one kind, and the 2 kinds of algorithms in anomaly detection. In clustering, it's k-means. Multi-class and 2-class has a pretty big list of algorithms. So there's fast training and blah. In 2-class, there's 2-class SVM, 2-class average, 2-class logic, 2-class Bayes, and a whole lot of them. And under regression, there's a whole lot of different kind of algorithms which exist. I'm not going down into which of these algorithms you want to use where. That can happen on an iterative basis. The idea is that all these algorithms are included in the Azure machine learning toolset, and you can consider them as black boxes, which means that you will just input the value and it's going to throw you an output, and it's going to help you train your model. Now, without wasting more time, let's just directly get into the demo of what I'm trying to show about how you would want to use and how would you want to use a 2-class and a multi-class algorithm. So let's start with the 2-class classification example. So as you can see, it's a very simple model that I have created. Okay, I'm getting a set of data. You got 5 different columns. The first one is called the class, which is essentially the binary class. It's got either a 0 or a 1 in it. And it's got the sepal length, the sepal width, the petal length, and the petal width. And based on those, the class can either be a 1 or a 0. We think about the class as a different kind of 2 different kind of flowers, which have their own characteristics. So now what I'm going to do is I'm going to run an algorithm, and since I want to predict whether the flower is of class 0 or of type 1 by inputting the sepal length, the sepal width, the petal length, and the petal width, I'm going to use a binary 2-class algorithm. As you can see, I've used a 2-class decision tree. I've trained my model, and finally I have scored and evaluated my model. Now if I click on score model and I visualize what the result is, I will notice that there are 2 additional columns which have been added, which means that for a 2-class algorithm, there will be 2 additional columns which are added. One is called as scored probabilities, and the other one is called as scored labels. The score labels is determined based on the scored probabilities. So if the scored probability is less than 0.5, it will be 0, and if it is more than 0.5, it will be 1, which really means that in the future, if at all I come across a particular flower which has a sepal length of 4.6, a sepal width of 3.6, a petal length of 1, and a petal width of 0.02, my scored probability will be 0.03, which is less than 5, which means that that particular flower will belong to class 0. So this is how this is going to work. Evaluate model is the last step, so we can always click on evaluate model and click on visualize and figure out. As you can see, this is a beautifully done model with 100% accuracy, and that's only because I've selected each and every column to go into testing. But the good thing is that of the trained model, whatever it predicted, it matched 100% with my test set, and that's the reason why you get a true positive of 29, true negative of 21, which means every time it predicted that the value is going to be false, it correctly predicted the value is going to be false, and it correctly predicted the value is going to be true. So this is how two-class example works as to how do you score the model and how do you evaluate the model. And there are various kinds of decision trees that you might want to use in order to determine that. Okay, so this was two-class algorithm. Now let's try and see how is it different from a multi-class algorithm. So if I click on a multi-class thing, what I've essentially done is that I have got a data set which is, let me open it for you to give you an idea, a data set where column 1 has all the 26 different letters, as you can see, and column 2 to column 17 are all the other parameters which have values pertaining to that particular letter that we're talking about. And the training algorithm is taking this entire data set as an input and is using a multi-class algorithm in order to find some kind of a pattern between column 1, which is the letters, with all the other parameters from column 2 to column 17. And once it has that value, in the future, if at all we can give inputs of column 2 to column 17, it can predict what that particular value for column 1 will be. So that is the entire idea of this. Okay. So as you can see, I have imported the data. I've split the data into my training set and my test set. I've used a multi-class decision tree, and now let's look into the score model as to how does that really look. So I can just go to scored data set. I can click on visualize. And what I'm going to notice out here is that column 1 remains the same. Column 2 to 17 remains the same, but there are 26 new columns which has been added. Okay, and you can see it's a scored probability of each of the different classes which exist, and there are 26 of them. Okay, the way this machine learning algorithm is working is that it's trying to associate a scored probability score on each of the columns, or rather on each of the classes which exist. So for J, it has predicted, so if at all it's predicting in the future and it gets an input of column 2 to column 17 as this, then you will notice that a scored probability of A is this. A scored probability of everything is very, very minimal, but the scored probability of J is really high, 0.97. So the probability the particular class with the highest probability is the scored label for that set of values. That's the reason why a scored label of J gets associated with that set of values. Okay, so this is how it's working. And if at all we click on evaluate the model, we can right click and click on visualize. What you're going to notice is something called as a confusion matrix. It is named not really to confuse you, but I think the most important parts of confusion matrix is overall accuracy and average accuracy. You can see that overall it has an accuracy of 0.8. It found out through an average accuracy of 0.98 times as to what the value is when it compared it to the test data set. So this is how one can understand how multi-class algorithms work and how you can score and evaluate the results of that. So that's all for now. I'm going to make a few more videos about what are the other kind of algorithms and take a deep dive into them, namely the regression kinds, the clustering kinds, and the anomaly detection kinds. So do keep tuning in, and thank you again. If at all you have any feedback, my Twitter handle is @AdarshDatta. Thank you so much. Cheers.